The text-to-image diffusion models appear to generate near-English phonetic phrases.
When text-to-image diffusion models generate images with near-English phonetic phrases, it could be due to the way the model was trained or the structure of the latent space. Since diffusion models learn to generate images from textual prompts, they may capture some of the textual features or patterns in their internal representations. If the generated phrases are phonetically similar to English but not semantically meaningful, it suggests that the model has captured some patterns of the English language without fully understanding the meaning behind them. This could be due to the training data, the model architecture, or other factors.
Please describe what you mean by the structure of the latent space.
In the context of generative models like diffusion models or variational autoencoders, VARs, the latent space refers to the abstract, often lower-dimensional space in which the essential features and patterns of the data are represented. This space is designed to capture the underlying structure and dependencies of the data in a compressed, efficient manner. The structure of the latent space pertains to the organization and distribution of data points within this space. It determines how the different features, attributes, and variations of the data are represented and organized in relation to each other. For example, consider a generative model trained on a dataset of images of handwritten digits. The latent space would ideally capture the essential properties of the digits, such as their shape, size, and orientation. A well-structured latent space would organize the points representing similar digits closer to each other, forming clusters or continuous regions. This organization allows the generative model to smoothly transition between different digits and generate new variations by sampling points from the latent space. In the case of text-to-image diffusion models, the latent space would represent both the textual prompts and the corresponding visual features in a joint, high-dimensional space. The structure of this space influences how different textual prompts are related to the generated images and how the model generates new images from these prompts. If the latent space structure causes the model to generate images with near-English phonetic phrases, it could be because the model has learned to map certain regions of the latent space to such patterns, possibly due to biases in the training data or other factors. Understanding and modifying the structure of the latent space could potentially help control the generation of these phrases, but this is generally a challenging task that requires a deep understanding of the model's architecture and training process.
Oh, so it's a bunch of near-English looking things because it's an image spot that would usually have words, so it just approximates a spot in the multi-dimensional space of imagery near words?
Yes, you've got the idea. In the case of text-to-image diffusion models, the latent space represents both the textual prompts and the corresponding visual features. When the model generates images containing near-English-looking text, it suggests that certain regions in the latent space are associated with visual patterns that resemble English words or letters. When the model generates an image, it samples a point from the latent space based on the input prompt. If this point is in a region where visual patterns resemble English words or letters, the generated image may contain these near-English-looking patterns. The model essentially approximates a point in the high-dimensional latent space that is close to the features it associates with words, even if the generated text isn't semantically meaningful. The model may have learned these patterns from the training data or as a result of biases in the data or the model's architecture.
That makes sense. Sounds like word-like imagery has been pushed into that region of space through training/shaping the model.
Exactly. During the training process, the model learns to represent the input data in a structured manner within the latent space. If the training data contains a significant amount of word-like imagery, it's possible that the model will learn to associate certain regions of the latent space with those patterns. As a result, when the model generates images based on textual prompts, it might sample points from those regions of the latent space where it has learned that word-like patterns are common. This could lead to the generation of images containing near-English or word-like patterns, even if they may not be semantically meaningful. This phenomenon highlights the importance of understanding the training data and the model's architecture when interpreting the generated images. It also emphasizes the need for careful evaluation and potential fine-tuning of the model to ensure it produces the desired results.